It is a center for rural development that I built in Pondicherry. This building began in my mind when I was 20 years old in a humanities class in my architecture college in hometown Mumbai. That was perhaps the first time I understood the catastrophic levels of social and ecological devastation that happens in our country in the name of economic development. I was so helpless on that day that I just couldn't see any meaning in what I was doing. I was here being trained as a professional architect, and this continues to be the state of our country. How does that even make any sense? How do we reconcile these opposites of economic development and ecological intelligence? It was on that day that I decided that I'm going to be a change maker. In my heart, I am an unshakable optimist, and I always believe that the future can be beautiful. But the question I was asking myself on that day was, is the future going to be beautiful because of me or in spite of me? I believe that the starting point for any enduring idea can never be money. The starting point always is the will. I left my city, Bombay, to discover my country, found myself in perhaps one of the most backward areas in rural Tamil Nadu. I did not know the language at all, in the midst of several alcoholic villages. Teamed up with an NGO which had a piece of land and a shoestring budget. And this was a wonderful opportunity for me to prove to myself and to everybody else that money is not the starting point. If it can be done with a shoestring budget like that, perhaps the budget in which only the interiors of this room have been done, if I can build something which can get selected by the United Nations Environment Programme as a model for sustainable development in India, it only shows what is possible, just with will and many other qualities. So how do we harmonize these opposites of economy and ecology? And if to add to that, we add social responsibility, which is a factor of people, all these three seem like completely different circles. How do we even reconcile them? What is that sweet spot in the middle which can bring these three together? In my understanding, that sweet spot is innovation. Because the question is at this level, and if we keep moving in this plane, we will always have a thesis and an antithesis, but we can never have a synthesis. The synthesis can be only from a much higher plane. If the question is from, say, level 1, the answer has to be from level 10. And only then we will be able to bring these three together. So when I started the rural development project, I found myself having so many different challenges. There was the challenge of design, there was the challenge of ecology, climate, technology, so many challenges. For the sake of today's conversation, I'm going to pick 3 stories from 3 of these challenges. The first being ecology. So this little plot of land that we had was about 5 acres and it was completely devastated. The local political goons were using it as an illegal mud quarry. Parts of the land looked like this. And this was the starting point. So I decided that it had this abused feeling of a land, almost like a little child. So I decided that I'm going to start soil healing programs. for which we did a topographical survey, and the point at the lowest contour, we dug out a little portion like this, just so all the rainwater gathers there. And because we didn't have budget to even buy steel and expensive bricks, I was researching on how I could make use of this very soil to make the bricks. And I was able to develop certain technologies over a period of one intensive year of research, make bricks with it. So from this very reservoir, we built the entire 5-acre complex. Sustainability is about closing the loops. It's not about putting raw material, capital, and labor at one end and going in a linear process with the finished product and waste at the other end. It's about a cyclical loop where the waste of one process becomes the wealth of the next process, and so on. That to me is sustainability. I was, as Mahendra said, throughout this process able to train more than 450 local, completely unskilled villagers who did not even know how to use a measure tape, into extremely high-level technicians, masons, building craftsmen. These bricks that you see over here, we made 9 different types of bricks, different for columns, different for walls, different for roofs, in order to optimize material. Otherwise, you have a standard brick, and irrespective of whether you need that size or not, we just keep using that size everywhere. So over here, we actually took not just one extra step, but perhaps 100 extra steps to optimize at every level. These blocks are unfired. They are made from the earth with a pinch of cement, what we call compressed stabilized earth blocks. They are built to a precision of 0.5 millimeter. Again, by training local people. The wet compressive strength of these bricks, just to compare it with the normal bricks that we use for all these curtain walls, the wet compressive strength is in the range of, let's say, 35 to 37 kgs per centimeter square. These had a wet compressive strength of over 80. So it was more than double. The volume of this brick is 3 times the volume of a wire cut brick. So if a wire cut brick was costing me 8 to 9 rupees, 3 of which would have cost me in the range of 24, I built this for 6 rupees. So a quarter of the financial cost, and of a far superior quality in strength, abrasion resistance, wet compressive. Even the foundations, there is absolutely no steel or concrete in the foundations. We neatly marked out the areas where we wanted to put the building, dug out the soil, sieved it, added a pinch of cement, and rammed it layer by layer back into the ground. The foundations are only 3 feet deep, and a 3 feet deep foundation is capable of taking a 7-story building on it. So it kind of topples all our ideas or prejudices that we cannot build without using steel or concrete on its head. The second story I have picked for today is that of climate. Now in Pondicherry, we have 3 seasons: hot, hotter, and hottest. In the hot season, you're in the range of the late 30s, and in the hottest season, you're in the late 40s. The relative humidity around the year is in the range of 85%. Now in this harsh, challenging climate, how do we create thermal comfort for no cost? We don't have money for air conditioning, and it's not even suitable. So how do we do that? I was researching and I found the answer in something that was right in front of me. The most comfortable spaces anywhere in our country. Can somebody have a guess? Absolutely. The most comfortable space, as Sir pointed out, is under the shade of a tree. Because a tree does 2 things: provides shade from the sun and maximizes ventilation underneath. So the idea for me as an architect is, how do I design a building like a tree? That is the challenge. The building has to be a tree. How do we do that? I studied several local traditional buildings, whether they were temples or palaces or even vernacular homes, and everywhere I found a strikingly similar response. Each of these people would have asked themselves the same question: how to design a building like a tree. So this is Sharanam, the main multi-purpose hall of Sharanam. And over here, I have employed over a dozen solar passive strategies. So it can be extremely hot. You will be sweating outside, standing on the highway. The minute you enter inside the building, you're perfectly comfortable. The breeze starts blowing in your face. You don't even need fans. The building doesn't even have fans, and it's perfectly comfortable. So, several strategies. For example, the longer side of the building faces north and south instead of east and west. So you cut across the path of the sun. You minimize solar gain right in a simple orientation. I did wind studies for over a year and placed the building exactly perpendicular to the summer breeze and designed the pillars in order to funnel the breeze in. And that's how outside there's no breeze, but inside you have tons of breeze. Stack effect. Skylights in the roof. So all the hot air rises up, is taken out from the means of these skylights, and cooler air is brought in from below. Green ground cover all around the building. So all the hot air cools down before entering the building at a lower level. Use of water bodies both outside the building as well as inside in order to facilitate evaporative cooling. Use of cavity walls where air acts as an insulator, and ventilated walls in all the walls facing the sun. Vertical gardens, again, to shade all the walls. Use of indigenous trees which are appropriate for that climatic zone. So for example, trees which are crowning above human height. So not trees which start the foliage from the bottom, but the foliage has to start above the human height so that the breeze, it maximizes the flow of breeze. Roof gardens acting as excellent thermal insulators. Heat reflecting paint on the roofs. Cool surfaces. This is something that we all underestimate the power of. Over here, I have used different types of cooling floors in this photograph, as you can see. So these is what, when we were sieving the soil to make the foundations as well as to make the bricks, these are all the pebbles that came out of the soil. So we just collected all the pebbles and made all the floors with those pebbles. And the other flooring that we did was these colors that you see. It's a variant of the ancient Kerala technique, which uses cocoa powder as the basic material with lime, hibiscus flowers, the red hibiscus flowers, and kajal. And you cannot believe how cool that floor is. Nobody wants to even get up. So whenever you're in contact with cooler surfaces, all of us know the principles of radiant cooling. If the mean radiant temperature of the floor's wall and the roof is below 36 degrees, which is the human body temperature, you automatically always feel comfortable. Because the building is not radiating heat to you, you are radiating heat to the building. Such a simple principle. And of course, radiant cooling pipes everywhere under the floors. The water that flows in these radiant cooling pipes is again the water that is harvested from the roof, brought down through pipes, stored and circulated at a very slow pace from under all the floors. Because as we all know, water holds twice the amount of heat for the same volume of masonry. So it actually drains heat out of the building through the medium of water rather than pumping heat out of the building through the medium of air, which is what air conditioners do. And as a result of all this, what you get in the end is a building which acts like an earthen pot. the entire building is like an earthen pot, which our grandmothers used to have at home when we didn't have fridges. And all of us remember as children how cool that water is. So over here in the morning, you can actually see little water droplets on the outer surface of all the walls because the inner temperature is so cool. Use of daylight everywhere in the building. Even acoustics. This is the chief music composer of the Titanic track, who also performs with, who used to perform with Michael Jackson as well. And he heard about the building, about the acoustics of the building, and he actually came down from New York to perform here. You can stand at one end of the building, and we have designed the roof in such a way that a person at the other end can actually hear perfectly without any mics. It's a rural development center. We cannot afford expensive acoustics. So it's almost like a modern version of a whispering wall. The third story for today I have picked is technology and the impact of innovation. So one of the main challenges I was facing right at the outset was, because we wanted to house 500 people in a single space, I needed a large column-free roof. How am I going to build that? I don't want to use RCC and steel. It would become too conventional. What can I use? So over here you see, we made these thin, absolutely thin, like 1 inch thin shells in ferrocement to be used as lost formwork for absolutely lean beams. So these are the shells going up. And then for about 3 months, I was actually studying these old ancient Egyptian techniques of Nubian arches and vaults. In India, all the domes that we see mainly in places like Rajasthan are extremely heavy. They have very high thermal mass. So that is not suitable because it can give you a lot of construction waste on your building site, those kind of buildings. So I was studying these techniques which a French engineer friend of mine had further developed, and I worked on it even more, by which I was able to bring down the thickness of the roof drastically. So I had a span of 10 meters and I had to span it. In a conventional brick vault, the thickness of the roof would have been equal to my height. It would have been a 5 feet thick arch going from one end to the other. And because of all these studies and research that I did, I was able to bring down that 5 feet to a mere 4 inches. So it's actually a paper thin roof out of perhaps the heaviest material, which is earth. So the way we built it was, I designed these 2 templates which define the shape of the arch, and placed these 2 templates at a fixed distance of 6 meters and then just fixed it over there. Once the templates were fixed, they don't move. I'll tell you why it was 6 meters, that's another funny story. And the first row of bricks is placed on the template. So as you see, even the bricks are reducing in size. They are not the same bricks. I was telling you in the beginning that we made bricks of different sizes. So the reason for that is that over here, I wanted to build a zero debris building. So when the building is finished, there should be absolutely no debris on the building site. How do we do that? Because roofs normally have a lot of shuttering. In fact, old domes, ancient domes everywhere in the world are built by stacking bricks, plastering it, and then stacking the bricks on top of it and then removing all the debris from underneath. So imagine it's like a positive mountain of debris and then a negative of the roof. So that's the amount of construction waste these things generate. So I have decided that I don't want any debris. How do we do that? So I designed the whole roof such that it is not only stable when the 2 halves of the arches meet, but it is also stable before the arches meet. There is a sentence by Leonardo da Vinci where he says that an arch is 2 weaknesses combining to make a strength. But for me, the challenge was I had to make 2 strengths combining to make a greater strength. So how do we do that? So I had to design it in such a way that when these bricks were placed one on top of the other at an angle, the forces acting on each brick are, as we all know, the line of thrust is composed of the vector which acts horizontally and the weight which acts vertically. I had to transfer the line of thrust of each brick exactly to the center of gravity of the previous brick. And only then will the brick not fall at the time of construction. And from the second course of brick onwards, they are just stuck to the previous course without any support or shuttering underneath, again only with clay, only with soil mortar. There's only a pinch of cement, about 5%, both in the brick as well as in the mortar. So you have two masons on each template going tuck, 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 and meeting at the center, and two masons on the other template, and then they come closer and closer together and meet in the center. So you see these thin strings which are acting as guidelines, and the mason is placing the brick just underneath it. So this was the reason, a very funny reason, why those templates were 6 meters apart. Because these are laundry lines on which we dry our clothes, and they were sagging after 6 meters. So I just had to pull them stretched such that the whole vault can be completed. So we had 8 masons on the vault. I was the 8th mason, and this is how we were making the arches fly out from the base and meet at the top. The whole technique was about how to make the arch like a catenary. So catenary, as we all know, is just when you hold a chain and all the links of the chain are acting in pure compression. So when you inverse that, you have an inverted catenary where each member is acting in pure compression. There are no tensile forces anywhere on this arch. And hence, it is able to stand. You can see actually the thickness, it looks paper thin. It's only 4 inches. These are the only tools we used to make this entire structure to a precision of 1 millimeter. We wanted to make it modern, we wanted to make it highly engineered, and well, this is the toolbox. For the entire brick, for the entire vault, I was calculating that if I had made it with a conventional method of using the normal burnt brick, I would have used 10,000 bags of cement. So, well, can you guess how many bags I ended up using for making this gigantic roof? Any guesses?
Around 1,000 bags?
Okay, anybody else?
500 bags.
Okay, anybody else? No, I did. A pinch of cement, both in the mortar as well as in the brick. So I built the entire roof with 33 bags of cement.